Hello and welcome back to my channel. Today we'll be presenting a very short video, Puzzle-24, an extension of Puzzle-32. So I'd like to start with a request. Those who have not seen this Puzzle-32 video, please stop here, go back to see that Puzzle-32 and then come back to Puzzle-24, which is just extension of the earlier one, Puzzle-32. And it reads like that 32 numbers 1 to 32, each being used once and once only, are arranged in such a way that sum of any two neighboring numbers is a square. So you can see what it means. Okay, that was the earlier puzzle, and the question I addressed is it a unique solution? And what I tried to establish that yes, it is a unique solution. And to be honest, I didn't have in my original plan to extend this puzzle further, say to puzzle 24, but it came through a motivation from one of my YouTube members, Mr. Argha Bagchi. He made a comment on the last video, and the comment reads like, one can try with different sets of numbers in the same way. So he has agreed with, he has no objection with the way I have done the problem. And now it rates maybe 1 through 24 to reach out up to the square 36, and 1 through 40 to include the square number 64. And finally he made interesting exercise. So the problem is similar, that you have to arrange numbers 1 through 24 or 40, each being used once and once only, in such a way that sum of any two neighboring numbers is a square number. So that is as simple as that. Now the rationale behind his choice of number 24 and square 36 and number of numbers 40 when to include square 64 is quite understandable, because we use 32 number of numbers to have a maximum square of 49, and the next higher square is 64, and 32 is just half of 64, right? So if you go higher, that is the next square number 81, then intuitively we can say that it is 40, the number of numbers, and to get the maximum square 64. And if you want to go down, the lower square that is 36, and the number of numbers would be 24. So that's why he has chosen 24 and 40 for the squares to be included, 36 and 64. So it's all right. Now the question is there any solution, or more than one, or a unique solution, or there is no solution? So let us explore the possibilities. Well, we need this kind of chain link. If P, Q, R, Q is in the middle, and for a given Q, simply search for a pair of unique numbers P and R, so that both the sums P plus Q and Q plus R square numbers. That is the condition of the puzzle. So your strategy is simply for a given Q, you have to find unique P and R, right? So how we can do that? So step 1, first of all, let us see the pairs, listing of all possible pairs whose sum are squares, 4, 9, 16, 25 and 36 also included this time. So let us see. For example, for 4 is 1, 3, 2 is obviously not considered, the same number twice. Similarly for square 9, 4, 5 and then comes back 5, 4, and henceforth all the numbers are just repetition, so we are not considering. Similarly for 16 up to 7, 9, and similarly for 25 and 36. So it goes up to 17 and 19 if you see the series, and then the next number pairs would be 18, 18, which is excluded because the same number is used twice. Okay. So this is my strategy and step 1. But the question is how to ensure that P and R are unique. This P and R are unique for a given Q. And more importantly, what are those Q numbers for which maybe you have some unique P and R. So these are the questions to be explored next. So what to do? Step 2. Finding the numbers as Q which are in 2 columns only. So that is the first answer to the first question, that to ensure and to find those Q whose pairs P and R are unique. And the answer is that you find just those Q which are in 2 and only 2 columns only. Okay. So you can easily see, and that ensures that if it is only 2, so P and R uniquely and automatically come. Okay. Because okay, that will be clear through the example. Let us first see what are those Q, and if you inspect that, you will see that there are 6 such numbers which are appearing in 2 columns only, namely 25 and 36 square, and those numbers are 19 through 24, 19 through 20, 19 through 20. So these are the numbers which are only in 2 columns. Okay. So how to ensure? So 24 is in these 2 columns. So the connecting or associating pair is 12 and 1 and no number else. So 24, if you take it as Q, then P and R obviously are 1 and 12. So you get a unique triplet 1, 24, 12. So 1, 24 and 12. And you don't have any other option with these numbers, right? Similarly, you can get the other triplets very easily and you can check it. But one thing we can claim that this is unique. So this set of triplets are uniquely chosen, that we are confident with. Okay. So we have deliberately found a logic for ensuring P and R, that is finding the numbers which are in 2 columns only. But what are the other possibilities that the numbers are appearing in how many columns? Okay, if it is 2 already done, then we can check for 3 or onwards, right? So what if Q appears in 3 or more columns, right? So obviously then Q can be linked to 3 or more numbers as P and R, right? Because Q appears in more than 3 or 4 or 5 columns. If it is so, then 3, 4 or 5 number of numbers would be there as P and R, right? So for example, if Q is 3, then P and R can be chosen from different columns as 1, 6, 13 and 12. You see, 3 plus 1 is 4, 3 plus 6 is 9, 3 plus 13 is 16 and 3 plus 22 is 25. All are square numbers. Right. Similarly, so we see that for Q equals to 3, I see that that Q or 3 appears in 4 columns. Here, for example, if Q is 4, then it appears in 3 columns, 5, 12 and 21 are the numbers to give the squares when added to 4, right? So we can conclude that P and R not automatically unique. Okay, not automatically like the earlier case. So we have to search for P and R, and that would be a matter of inspection, or you can say called trial and error basis. So yes, of course, this is logically we can go ahead with this trial and error basis, but for the time being, let us keep aside this possibility, and we can go back to the other possibility here, that we have checked the numbers which are in only 2 columns, then we have checked in 3 or more than 3 columns. Then what is left? Of course, what if Q appears only in 1 column? So that is also a possibility, in 1 column. So let us see what happens if it is so. So Q can be linked to only 1 number, right? Because it is in 1 column, and in that column 1 pair is there with that Q, and that pairing partner can be associated with this Q only, right? So we can conclude that both the ends or both the hands of Q are not satisfied. You cannot have P and R both. You can have either P or R from that single column where this Q appears, right? And thus the main conclusion that the chain cannot be closed to give a cyclic chain. If both the hands are not satisfied, then you cannot close the chain. You cannot get a cyclic chain. So if such a Q exists, there is no solution we can declare, right? Now the question is now, is there really a Q, such a Q in our problem? So I would request to look back the tables of pairs again. So here the table started with for all the squares and the pairs. So the question remains that is there a Q that appears in only one column? And interestingly for this problem, yes, 18 is that number. Here marked red, you see, you inspect carefully that 18 is the number which appears in only this column and nowhere else. So problem almost solved. We can say safely there is no solution to this problem. So if you can find any flaws in my logical steps, if you please make some comments, I'd be happy. Think over that. Until then, goodbye and thanks. So thanks once again for watching this video. Thank you.